Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is IGCSE Physics. It's paper 4. This physics is theory paper, and this is the standard physics. The code for this subject is 0625. We have selected May-June 2023 4-3 paper. This paper 4 belongs from the zone 3. In this video, we are going to solve only a single question of this paper, and that is question number 9. And this question number 9 is related with the space physics. Basic aim of this video is to collect questions related with the space physics for our Cambridge O-levels students, because this space physics topic is the new topic which is added into our syllabus. So let's start today's paper. Question number 9 we are going to attempt, and let's go to the paper. Okay, so here we have that paper, and the question number 9 of that paper is showing up on your screen. So it says the figure 9.1 shows the sun as the central dot and the planets Saturn and Jupiter and Earth labeled S0, J0, and E0. The planets orbit the sun anti-clockwise from the Earth's orbit. The planets appear aligned. So right now they are aligned with each other, and they all are orbiting anti-clockwise. So they all are orbiting anti-clockwise like this, okay? So their question is, assume that the Saturn takes 30 years to orbit the sun, and that Jupiter takes 12 years to orbit the sun. So on the figure 9.1, mark the position of the Saturn and Jupiter 5 years after the original position shown. Label these positions S1 and J1. Show your working. Okay, so if we talk about the Saturn, in 30 years, it will complete 360 degrees orbit around the sun. And the Jupiter will take 12 years to rotate 360 degrees. So first of all, I will calculate that Saturn in 5 years will move how much angle. So let me show you the calculation. I have done those calculations. So let me bring it here. The calculations are here. Okay, for Saturn, because the Saturn will complete its orbit in 30 years. So in 5 years, it will move how much angles? So 5 by 360, 5 by 30 multiply 360, and that will be 60 degrees. For Jupiter, because the Jupiter completes its orbit in 12 years, so in 5 years, it will cover how much angles around the sun? So that will be 5 by 12 multiplied 360, and that will be 150 degrees. So now I will show you, I will put my protector. So you can see I will put my protector because they are orbiting anti-clockwise. So here was their initial position. So after 5 years, the Saturn would cover 60 degrees. So I will put a dot here, and the Jupiter will cover 150 degrees. So I will put a dot here. I hope you can understand. This is for Saturn, and this dot is for Jupiter. Then what I will do, I will remove that, and you can see here this position I have marked this as J1 and this position as S1. Hopefully you understand this. Let me show you the marking scheme. Look at question number 9, A part. Its marking scheme is showing up. Our answers are right. You can see this. It's okay. Now the next part, that was a 3 marks question. In the next part, this is question number 9. It's B part. He says on the figure 9.1. Mark the position of the Saturn and Jupiter 20 years after the original positions shown in figure 9.1. So again, I will do the same process. I will calculate the angles. So I'm going to calculate the angles for the Saturn and the Jupiter. This time the time is 20 years. So the Saturn, which completes its orbit in 30 years. So in 20 years, how much it would have moved in the terms of angles around the sun. So it is 20 by 30 multiplied 360. So the Saturn will move 240 degrees. Now, about the Jupiter takes 12 years to complete its orbit around the sun. So 20 divide after 20 years, so 20 by 12 multiplied 360, and it will be 600 degrees. In one cycle, we have only 360 degrees. So that means it has completed more than one cycle. So from 600 degrees, I will first of all subtract the 360 degrees for one cycle, and the remaining angle will be 240 degrees. So that means from the original position, both the planets, sorry, have moved to 240 degrees. Their position will be at 240 degrees. With the help of the protector, it is difficult to show 240 degrees. So if you want to show 240 degrees moving in anti-clockwise manner, so what we will do, we will subtract that angle from 360. I will get 120 degrees. So that position can be shown by 120-degree angle clockwise. So basically, it has moved anti-clockwise to 40 degrees. But to show with the help of the protector, what I'm going to do, I'm going to use a trick. I'm going to move through clockwise. How much? 360 minus 240, that's 120 degrees. So both the stars will move same angle. So this is 120-degree clockwise. Basically, they have moved anti-clockwise 240 degrees, so you will reach the same position. To show with the help of protector, I am going 120-degree clockwise. Okay, so this is that position. So what I will do, I will remove my protector, and then I will put the dots here. So that position will be J2, and this position will be S2. So hopefully you understand. So let me show you the marking scheme of this part. The marking scheme of this part is showing up here. So this is how you will show this. I hope you understand this. It's a brand new question for O-level students. Okay, now we move to the question number 9B, second part. He says, state what is observed from the Earth's orbit after 20 years. After 20 years in that position, that Jupiter and the Saturn, they are on the same position. So when you look from the Earth, they seems to be aligned with each other. There will be Jupiter, and behind the Jupiter will be Saturn. When you look from the Earth, they seems to be aligned with each other. So my answer is, from Earth, Jupiter and Saturn seems to be aligned with each other. So here we have the marking scheme. You can look at the marking scheme. This is our answer. So hopefully you understand. Okay. Now we move to the next part. He says that is question number 9. It's C part. It's first portion. He says, choose two words from the list to describe each planet. So gaseous, large, rocky, and small. These are the four words. For Jupiter, Jupiter, is a very huge planet. And it's gaseous planet, and it's large. So gaseous and large. And for the Earth is rocky and the Earth is small. So for Earth, it's rocky and small. For the from Jupiter, gaseous and large. For Earth, rocky and small. Let me show you the marking scheme. So you can look at here. Our answer is right. Okay. So we are going to the next part. He says this is question number 9C part. It's the second portion. He says the average density of Jupiter is much less than that of the Earth. The gravitational field strength at the surface of the Jupiter is greater than that at the surface of the Earth. Explain how these differences in density and in gravitational field strength are consistent with your answer in the C first part. Why the Jupiter's density is less than that of the Earth? The reason is the Jupiter is basically made up of gases, and it's a gaseous planet, and its volume is huge. So that's why its density is less than that of the Earth. The Earth is made up of rocks, and its volume is small, so its density is higher. So, and on the gravitational field strength depends upon the mass of the body. The Jupiter also, although the Jupiter's density is less, its volume is huge, it's made of gas, but the mass of the Jupiter is larger, much larger than the mass of the Earth. The mass of the Earth is smaller as compared to the mass of the Jupiter. That's why the gravitational field of uh, is greater at the Jupiter's surface because its mass is huge it's larger as compared to the mass of the Earth. So here I have written some answers. I've tried to wrote those answers. Jupiter's density is less because it is made of gas and have larger volume, whereas Earth is rocky and its volume is smaller. About the gravitational field strength, mass of the Jupiter is more than that of the Earth. That's why it has more gravitational field strength. This is my answer. If you look at the marking scheme carefully, question number 9C, second part, the marking scheme is showing up here. So you can read this marking scheme. I have already checked my answers with this. Okay, so this was the question number 9C, second part. Now we are going to the next part. That is the question number 9, and it's a D part. It says the average density of Jupiter is 1300 kg per meter cube, and its volume is 1.4 expo 15 kilometer cube. Calculate the mass of the Jupiter. Okay, so if you know the density, you know the volume, you can calculate the mass. Mass is equals to density multiply volume. That is very easy. But there is a problem. If you look at that in the unit of the volume here, that is meter cube. The unit of the volume here is kilometer cube. The units are not consistent with each other. So what I will do, I will convert this kilometer cube into the meter cube. In 1 kilometer, there are 1,000 meters. So if you want to convert kilometer cube into meter cube, you will multiply with 10 raised to power 9. Then this volume will be converted into the meter cube. Let me show you. Okay, so here we have. So the density is 1300 kilojoule per meter cube. The volume is 1.4 expo 15 kilometer cube. To convert the kilometer cube into the meter cube, I will use 1.4 expo 15 multiply 10 raised to power 9, and that will be converted into meter cube. So it is 1.4 expo 24 meter cube. Now the unit of the volume here and here, they are consistent with each other. Now I can calculate the mass. The mass is density multiply volume. Density is 1300 kilojoule per meter cube. The volume is 1.4 expo 24 meter cube. When you multiply them on your calculator, you will get 1.82 expo 27 kg. 1.8 expo 27 kg. 1.8 expo 27 kg is the right answer, sir. So hopefully you understand this. So we are done with this question. And today in this video, we have solved from, this was 062543 May, June 2023 paper, and we have done question number 9 from that paper. This question is related with the space physics. And I have tried my best to explain you the concepts and the procedures. I have tried to write the answers. I have tried to show you the marking scheme so you can also write best answers. And the main aim of this video is to provide questions related to the space physics for our Cambridge O-level students. If you find this video useful, if you find this video interesting, please like this video. Please subscribe to my channel. Also share the link of this video with your class fellows, with your junior students, with your teachers. And share the link of this video on your WhatsApp groups, on your Facebook accounts, on your TikToks, on your Twitter, on your LinkedIn, so on your Instagram, because when you do this, you help me to promote my channel. Thank you very much for watching this video and taking our time. Have a good day. God bless you all.